Hello, everyone. Welcome back. First, next Monday, we do not have a lecture. Next week, we are going to have a lecture on Wednesday, but Monday, you have the day free, so nothing to do for Monday. No lecture Monday. So today, I want to continue with architectural patterns. I want to continue with software architecture. Previously, we talked about model view controller. We reviewed model view controller from the concept, the idea, and the implementation. We review some source code. The most important thing that I need you to remember, two things. Number one, be careful that you do not put functionality inside of your classes that are implementing graphical user interfaces. If you have a class that is a frame or a panel, the classes in which you are building the interface with the user, those classes do not have functionality. You do not put there methods that deal with data structures, that process informations, and so on. Always. The class is about the graphical user interface. Put there the graphical user interface. Be worried about the layouts and so on. But when you want to trigger some functionality, basically you call a method in a different class. That class should be part of your model. Is one class here. You can have several which implement functionalities. The ones that implement views are here. These call methods there. Keep functionality and graphical user interfaces separate. The other thing that we review is the same idea, but between the views and the controllers. The controllers, we reviewed this, your listeners, when we're talking about desktop applications, in particular in Java. Key idea when you are doing software that is big, do not put in the same class the extend JFrame and the implement action listener or mouse listener or whatever. Your listeners in one class, mouse, action, whatever, and your graphical user interface in a different class. Usually, the question that I have when I ask you to do this, separate controllers and views, is how to do that. We reviewed the source code before. We talked about this example, your assignment, your graphical user interface, and these controllers separate. Basically the source code that we review with the two classes and how one class add action listener, instead of having the this in the parentheses, have the name of an object that is from this class, the controller. Source code that we reviewed before, something for you to review. Hopefully you did it. If not, please review that. Separate models, views, and controllers. The first pattern. Moving forward, we have a list of patterns. The second in the list that I would like to review with you and be sure that you can implement is the Blackboard. Blackboard pattern. The idea of the Blackboard is pretty simple. You have this concept of a classroom, and in the classroom, you have this Blackboard, literally, well, a whiteboard, if you want to apply today scenarios. The pattern represents that space, that whiteboard in an analogy, in which different actors can put information or read information. The Blackboard is this shared space, shared memory, in which several different entities, objects, can write or read. In the pattern, we identify the Blackboard, the memory, and we identify the actors, two categories of actors. Number one, there are several entities that we are going to identify in the pattern and knowledge sources. In an analogy, those are students. Imagine a classroom, you have this whiteboard, and we have several students that if each of them have a marker, they want and can use the whiteboard to write something. It doesn't matter which student put something in the whiteboard, all the others can read that information. The whiteboard and every single one of the knowledge source, every single one of the students can write something or read something, all of them. The information is available for everyone. Moreover, connected with this idea, there is a particular actor here that is called the control. The control, in the analogy, is just like the instructor, the professor. It's only one. That one also can put information in the Blackboard or read from the Blackboard, just like the others, with one extra thing. This guy is the one that controls this space. Control. This guy can delete everything. This guy can remove one entrance from one student, and so on. Again, think about what can the professor do with the whiteboard, what can a student do, and it's basically the same, plus this idea of controlling things. Now, the most important thing here for you to remember, all the arrows that I am drawing here go from the Blackboard to the actors. There is no communication according with the pattern between, for instance, the professor and the student. This communication do not exist. Think about the example that I am using in a classroom in which any student can put information in the whiteboard. The instructor can put information in the Blackboard or remove the information from the students. But the professor cannot talk with the students and the students cannot talk between them. No communication between the sources of knowledge, no communication between the control and the knowledge source. Again, no communication between students, no communication between the instructor and the students. That is what the pattern represents. Good? So something at the center, the Blackboard, and use connections outside. One instructor, several students. The only communication happens because of the Blackboard. If I ask you how to implement this, if I ask you about moving this to a program, the program is going to be source code that we need to review. But we start with a class diagram. In a class diagram, from the scenario that I described to a class diagram, hopefully you agree with me that here we identify 1, 2, 3 elements, 3 classes. The class Blackboard, the class control or professor, and the class knowledge source or student, depending if you want to follow this diagram or my analogy. 3 classes. 3 classes. I am going to use these names of student, Blackboard, professor. We have several students in the scenario. I am talking about only one control, but several sources of knowledge, several students. Well, we're going to create several objects from the class student, but I only need one class. We're going to create one professor. I need the class. We're going to create one Blackboard. I need the class. 3 classes. Now, problem number 1. I have 3 classes, but according with the description that I shared with you, students and professor, they are going to be working concurrently. They are going to be writing or reading in the Blackboard, but 2 students can be writing at the same time, or one can be writing and the other reading. The scenario that I am describing is a scenario in which several things are happening at the same time. And if we have a program and that program needs to do more than one thing at the same time, if things could happen concurrently. Something that we need to implement that is multi-threading. And if we're working with Java, in order to implement multi-threading, we have two options. Option number one, the class thread. Option number two, the class runnable. If you are familiar with that, great. If not, homework. I need you to review thread and runnable. I need you to review a tutorial, something about how to work with multi-threading in Java. I am going to show you an example, probably it's going to help, but my homework, if the example is not enough, please read about it. You're going to do a next assignment. Your next assignment is going to need multi-threading, in particular with the class thread or the interface runnable, something that I am asking you to review. Here, two options, the thread class or the runnable interface. In my example here, I am showing you, I am going to use the runnable interface. If I told you that there is an interface called runnable, and that one I needed to make my objects concurrent. So an interface, my class, an interface, my other class, the relationship between those classes, my student and my professor, they are going to be connected with runnable, and they are going to be connected in this way. Hopefully you remember realization, inheritance between a class and an interface. The parent is the interface. So this class diagram is describing the scenario that I mentioned before. Student and professor, they are childs of the interface runnable, therefore they can work concurrently. They can be running several objects at the same time. Moreover, I have this class Blackboard that is going to represent this space for sharing memory. Somehow the student is going to be using the Blackboard. Somehow the professor is going to be using the Blackboard. Common error, guys. Here, the arrows go bidirectional. Bidirectional because here the arrows represent the flow of the information. Here the arrows represent I am writing or I am reading. Information go, information comes. Here, if I am talking about UML, if I am doing a class diagram, that arrow do not represent that the student is writing. That arrow represents that the object student, one object student, is calling a method in the class Blackboard, right? Do you remember UML? The arrow, the direction, is all about who is using what. That one is association. Association, you are calling a method. Do we need a connection in the opposite direction in the class diagram? Yes or no? I am talking about reading and writing things, student in the Blackboard. Okay, at least I have one no, and hopefully that represents everyone right now listening. You do not need this one because basically this arrow in UML represent that you have an object and that object is calling a method, and the method could be a method read or a method write if you want. It doesn't matter if I am going to call this one or the other one. Both in UML is this arrow, is using. So that is the first difference between the diagram that I showed you as the architecture, the meaning of the lines in the architecture, and UML connections. Similar with professor. Professor can read, erase, write in the Blackboard. It's all about this. In UML, professor uses the Blackboard, which means professor is going to call a method in the Blackboard. whatever is going to happen with that method, what that method is going to be, it doesn't matter. The connection is used unidirectional. Okay, so I have a student, it's going to be concurrently. I have professor, it's going to be concurrently. And I have Blackboard. And these two guys are using the Blackboard. Good. We need a main. We need a class that put the others to work. Let's think about my class main, the one that we usually create. We can call it classroom, just to play with the analogy. This is the class that is going to have a method main, the main that is public, static, and so on, the main method of the application. If I have that classroom with the main, and I have the other classes representing what I described before, what is the connection that is going to exist between the main classroom and a student? This and this are going to be connected, yes or no? And if they are connected, which is going to be the connection? I have a main. My main is going to create several students, probably the Blackboard and probably the professor. So if that is the goal of the main, to create everything, for sure there is going to be a connection. And that connection could be two options. And yes, one option could be aggregation composition. The other option could be association. What is the difference? The difference is whether or not you want variables global or local. Both options are possible. You can decide that you want a classroom. And in your classroom, you could decide that you want variables, students, several students if you want, an array of students if you want, and probably also a professor, one or more. If you do something like this, attributes, global variables, variables outside of the methods, then you are using aggregation. Or if you put the news, composition, up to you. Can we put those variables used inside of a method? Can I put this inside of some kind of method? So instead of having global variables, could I have only locals? And hopefully the answer is, yeah, so far it is possible. And if you do that, those variables local, then you can have association. So again, both options are possible. Association or composition aggregation. Which one is better? For this example, what is better? Global variables or local variables? And hopefully you agree with me, according with things that we have reviewed before. If you have the opportunity to do the same with locals or globals, it's always a good idea to try to create only locals. So in this scenario, it is possible. We can create all the variables local. We can create all the variables that we need used inside of one method. There is no reason for more than one. Probably the classroom class is going to have only one method. And inside of that one, we can create everything. And if that is the case, then my connection between classroom and student could be association with the arrow pointing in that direction. In the same way, connection with professor in the same direction, and probably something like this. If I show you a diagram, and the diagram is having this classroom, and classroom is pointing to a student, to Blackboard, and to professor, just like this. What I am telling you is that inside of the classroom, there is a method. And that method is creating local variables, student, Blackboard, and professor. And this asterisk here is telling you that there's going to be more than one student, probably an array or a list. And this one here is giving you extra information that there's going to be only one professor. And those numbers are because one control, several sources of knowledge, trying to match my class diagram with the idea in the architecture. So classroom, the main, student, several, Blackboard, one, professor, one, and student and professor runable. So student and professor are able to run concurrently, several of them doing something at the same time that others. This is the class diagram that represents the idea of the pattern, one implementation. And obviously, with this class diagram, you can move forward to the source code. Now, before doing that, there is any way in which I could remove one of these connections. In particular, what could be something that I can do if I would like to remove this connection here? There is any way in which I could have the Blackboard and the students and the professors or whatever other objects are could access that Blackboard that seems to be the core part of the pattern without creating that one, the object Blackboard in the main. There is anything in the design patterns that we reviewed before that could help us to have this common shared memory that seems to be only one Blackboard in the classroom that everyone is using? Probably if I put that diamond there and the reflexive relationship, that helps you to remember the Singleton pattern. If I use the Singleton pattern, I can create Blackboard as a singleton. If I create Blackboard as a singleton, I do not need this connection here because no one is going to create the Blackboard. One of the advantages of singleton is that it's not a variable that exists in any of my classes. It's a variable by itself. It's inside of the class. These relationships do not exist. Moreover, these two classes, the professor and the student, they do not need to have a reference to the Blackboard. They do not need to have a dependency injection, a parameter with a reference to the Blackboard. They can access the Blackboard as a singleton, which basically means that I can have these connections using the name of the class. Which solution is better? Having this line here and the main creating the Blackboard and probably passing as a parameter to student and professor the dependency, or making the Blackboard a singleton, which means this connection here and deleting the connection between the main and the Blackboard? Both work. You can use the one that you prefer. Dependency injection or singleton pattern. For this scenario, both are valid. I am going to show you the source code. In particular, just to review patterns, I am going to show you the solution, the source code for this one, for the one in which the Blackboard is a singleton. Source code for this idea. Number one, we're talking about a classroom. And inside of that classroom, something that I mentioned is, well, I have my method main. That classroom is the one controlling the system. Inside of the classroom, what I am doing is 1, 2, 3 objects, and I put those objects to work. Nothing else. 3 objects. Yeah, 3 objects that are going to be threads. Threads. Yeah, because we want those objects to be able to work, the 3 of them at the same time. Threads. And I am going to put in those threads one professor and 2 students. When you work with Java and you work with multithreading, what you do, number 1, to create objects from the class thread. Number 2, you can define your classes like we did, student and professor. And those students and those professors, they are parameters for the object thread. The object thread is going to encapsulate the objects that you create, in this case, professor and student. That is the only thing that I am going to do in my main, to create 3 threads, 3 things that can work at the same time. We need to review the classes, student and professor. Yes, I am going to show you. But step number 1, the main, if we're working top down, pretty simple, right? 3 objects. This connection and this connection. This connection, 1 object. This connection, the asterisk. In my example, that asterisk is value 2, represent the 2 students. That's it. This one here do not exist. The classroom is not creating the singleton, is not creating the Blackboard because it's going to be a singleton. So this. Question for your exam. This is the class diagram that we start drafting, but this is the implementation. And this is the implementation because this is what I need to do when I work with threads. Question in your exam. If I give you this source code, can you help me to create the class diagram that represents this source code? This source code, what I have is a classroom, and I am going to represent only the classes because I want to work with the relationships. I am going to ignore the methods and the attributes for now. So I have classroom, but it looks like I have also this class thread. But I have also this student here. And this professor there. So if I ask you for a class diagram, well, those 4 classes are the 4 classes involved. Okay, I have the classes. Next, the connections. Is there a connection between classroom and thread? And if yes, which is the connection? Oh, thread here, this is a variable, and that variable seems to be calling a method. So even if I do not know what is a thread, even if I do not know what is happening here, just knowing that thread is the data type for this variable, and just knowing that I am using that variable to call a method, just because of that association. Again, I am asking you as a homework to review multithreading with Java. I am showing you the example. If you have experience with multithreading in Java, you know exactly what I am doing. But even if not, you can figure out that, well, you are creating an object and then you are calling a method in that object. So the relationship is association, period. There is an association between classroom and thread. Yeah. What about the relationship between classroom and a student? or classroom and professor. There is any relationship between this one and this one, or this one and this one? Is association also, or something else? And hopefully you remember when we review the factory pattern, and hopefully you remember that. Hopefully you remember this line, association, but with the dash, not with the solid line. What is the meaning of this one versus this one? One is solid and the other is not solid. Why? What is that solid line representing versus what is the dash line representing? Any difference? Well, the interface was this one, the inheritance with the dash line. Right now, what we're doing is this one. So yeah, it's tricky. Dependency. This is realization. This is dependency. This is a special type of inheritance. You remember the interface, yes. And this one is a special type of association. What is the special case? Why this is not solid? Remember? The green one, we are creating the object and using the object. I create the object, local variable, and I use it. In the other, just like in the factory, I create the object, not calling a method. I never use it. So this is my class diagram for these things. Why? Because that is the way in which we do concurrency in Java. I need this and I need this. And the only reason because I need this is because I am going to put that one inside of a thread. That's it. Now, common question. You could be thinking right now, well, you are going to pass this one as a parameter to thread. So thread, if this one is my object, thread one, this one, I am passing as a parameter this student. Probably thread is going to do something with the student. Probably thread is going to call a method in a student. Thread is going to end doing something. So thread is going to have a relationship with the student. There should be some kind of connection between this guy and this guy, right? I am passing student as a parameter to thread. Thread is going to have access to students. So something that is expected is, well, that guy is going to use the parameter. And if he's going to use the parameter, it's going to be some kind of relationship. Yes, you are right. However, in a class diagram, usually, a class diagram is a model. In a model, the level of abstraction, the things that you show, is a decision that you take. What things are going to be visible and what things are not going to be visible, that is something that you decide. A common practice. I am going to show the relationship between my classes and the classes from a library that I am using, but I am not going to guess which relationship exists between these classes and my classes. For sure, this class thread is going to do something with the student, but I do not have access to the class thread. And I am not going to go and review the source code of the class thread that is a class from the library. So yes, some connection exists between these two. I am not going to show that connection in my class diagram. I don't care about that connection. This guy is a library class. And yes, I am sending this guy as a parameter. What is going to happen between them? Yeah, something. I do not need to show that something. And hopefully that makes sense. What I show is according with the source code that I am reading. I do not need to guess. Oh, this is going to be a diamond because this guy is going to store that one as a global, or this is going to be used as using. Nothing, no guessing. So my diagram for this source code is used like that. Classroom, association, thread, classroom, dependency of student and professor, and I am done. Clear. And exactly, it's the same thing that we described before with observer and observable. Yes, totally true. There is a connection between observer and observable, the two libraries. We do not show that line in our diagrams. We don't care about that connection. Yes. Good? So, fine. Next. We are talking about professor and we're talking about, well, they are going to be threads. We start with this diagram. And we decide in our version 1, this is version 1, that these two are going to be related with Runnable. Yeah. Professor, Runnable. Professor is going to implement the interface Runnable. Therefore, professor can run in a thread alone in the same way that is going to happen with student. The only thing that we need to do when we implement the interface Runnable is we need to override a method called run. And that method run is like the main for that class. I am going to be running professor and 2 students, and each of them is going to have its own run method, and that run method is going to be like the main for each of them. For instance, inside of the run method of professor, I can put this while loop. And hopefully you notice that I am creating a loop that is forever. This method, this professor, is going to be doing forever the actions that I have here. Forever, what? I am going to print this kind of hello, and then I am going to print these 2 things. 2 things. What? By now, I am sure that you know what is happening there. By now, you'll read that, the letters in white. And it's clear like, okay, this is a name of a class. And this get instance is like Singleton. And just because this is the name of the class, this is a static method. That static method is giving me an instance of the class Blackboard. I remember the Singleton, and therefore I can call methods. I can call the method read in Blackboard, which we can assume that is going to return some kind of value. And that value is the one that this professor is printing on the screen. So that lines in white is these connections. Professor calling a method on Blackboard. A method using the instance that I am retrieving because this is a Singleton. But obviously, in my example, is just a vanilla example. Nothing is happening here, nothing interesting. But you have the skeleton to create something more complex. The idea is this infinite loop is because this professor is going to be there working. Doesn't matter how many students are also running and working. And used to help the computer I am going to have this source code here. And help me, what is happening in that source code, the one that I put inside of the red rectangle between the lines 9 and 13? Can we understand what is happening there? Why those lines inside of the infinite loop? Hopefully, yes, hopefully like source code that do not need comments. That is the source code that you put in a program to ask your program to sleep. Sleep mean do nothing, and doing nothing mean please do not use the CPU. Do not use the CPU so others can use the CPU. In this particular case, I have this loop for the professor. I am asking the professor to print things. And in some point, after printing things and get information from the Blackboard and so on, I am asking the object to go to sleep for a second. A second is a long time. Go to sleep for a second so you are not using the CPU, and therefore others can use the CPU. Others, obviously in this example, the students. Print something, hello, go and access the Blackboard, retrieve information, print that information, go to sleep. That is what I am going to have the professor doing forever. What about the student? Student also implement runable. Student also is going to be running concurrently. The only thing that I need to have for a student is the same thing that I have for professor before. Override the run method. That is the only mandatory thing to have because we are doing this implement runable. And inside, what I am going to put in a student is the same thing that I put for the professor. I am going to put an infinite loop. I am going to have the student doing the same thing again and again and again. I am going to send the student to sleep also for 1 second. When the student is not sleeping, the student is going to say hello and also do some work. If the professor is going to be reading to the student, I am going to ask for writing. Professor access the Blackboard as a singleton. Student also access the Blackboard as a singleton, one for reading, the other for writing. Now, for this particular scenario, something that I am going to do for the students, because the professor is only one, but I have several students. Instead of having the students using the whiteboard randomly, any place, what I can do is to assign a particular space inside of the Blackboard to each student. So if I have 3 students, one can write here, the other here, and the other here. 3 spaces or more. What I am going to have is an ID for the student. If you remember, when I create the object students, I pass as a parameter to the constructor this number, 0 or 1. The only thing that I do with that parameter is to store the number in the variable, a constructor that receives an ID that stores the ID. So each student have an ID. And the only reason for that is when I am going to ask the student to write something into the Blackboard, 2 parameters for writing. Number 1, that is ID. So I am going to access the Blackboard and I am going to call this method with the information that I want to put in the Blackboard and also with my ID. So write, ID, and the information. The information here is only a random number. I don't care about the information right now. An example, vanilla example, write a random number. I have the professor, I have the classroom, I have the student. The only thing missing, the Blackboard. for the Blackboard. No inheritance, no implement anything. According with my diagram, nothing there. I want the Blackboard to be a singleton. I have been using the Blackboard as a singleton. There are some elements that we need to make this a singleton. A variable from the class, static. The method constructor private. Is the constructor is the one that is going to initialize the data structure that we're going to use. It's a Blackboard. It's this shared memory space. In programming, it's a data structure. Do you want a 2D array? Do you want to store the pixels like the whiteboard because you're going to draw something? Or you can just store a vector or a list or an array. And in my example, every single student have an ID, and that ID is going to be the position in the array, the position in the vector, in which those students are going to be able to store information. I have two students. I can initialize their space with 0. So it's like their space is empty for both. I need this get instance static method because of the pattern. You can remember this condition and the return of the instance, all that because of the pattern. And the only thing that is the functionality for the Blackboard, these two methods. Do you remember? Reading the index or writing the index and the information, adding data in a position, what data. This source code, together with the others, represent this idea of a common place in which I have several entities that can write or read. My example do not include students reading, but you can imagine that you can ask the student to read. You can ask the student to call the method read without a problem. And also represent this idea of the professor that is reading, can write also, that we describe as the Blackboard pattern. And this guy and these other guys are working at the same time. If you copy paste this source code, this source code, this source code, and the main, you will notice that all these things, these prints, are going to be on your screen like crazy in a different order. If you run the program several times, the order of the printing, which go first, the students or the professor, or which go next, is going to be used randomly, depending of which one take the CPU first. Blackboard, the architecture, the class diagram, and the source code. Your homework, and you have 1 week for that. Please review this and be sure that you understand what is happening here, in the same way that you understand what is happening with the model view controller. Any questions so far with the Blackboard? Clear? Good. Can you help me with the class diagram for this class? Again, question in your exam. If I give you this source code and I ask you for the class diagram, any idea of which classes are going to be involved and which relationships are going to be there? Association from student to Blackboard. Agree. Association because we're calling an action. Realization with Runnable is an interface. Yeah. Question, do we need to include in our diagram math and thread? Because math is a class and thread is a class, right? The answer, guys, yes, I could agree with that. But again, I want to point this. A diagram, a class diagram is a model. The level of detail that you put in your model is a decision that you take as an engineer. So if we want to have the complete diagram, math is a class, and therefore math should be connected with student. What should be the connection between math and student? Well, since I am using a method, there is a connection here with association. However, do we really need to show that association? Do we really need to show that class? Is that class really important to put there in our picture? And usually the answer to that is exactly. Usually that is the answer. So, guys, talking about the diagram, and if I am here teaching you UML and how to do the diagram, if this is 360, I will tell you, yes, that one is a class. Yes, that class is connected with the student, though the relationship association exists. Moving forward from that, moving from a student to professional engineers, usually we do not show this. The relationship exists? Yes. The class is there? Yes. Considering the level of abstraction of the diagrams, considering that we want to show things that are important for the reader, usually this one is kind of not exactly important, not exactly something that you want to use space in the diagram to show. The only thing that I am doing is to get in a random number. No need to have the connection. And similar idea could happen with thread. I am calling it leap. And this particular block of code is very, very common. Any program that is running threads is going to have something like this for the leap. So again, the class exists. There is a connection and it's association because I am calling a method. But usually, considering the level of abstraction, you are not going to include that in your diagram. So just by showing a student, that is important, Runnable, that is important, and the Blackboard, that is important. Those three, you cannot remove. But thread and math, you can ignore them and do not include them in your diagram. And hopefully this makes sense. Good? Okay, so Blackboard, done. Next, client server. For the client server pattern, the most important thing that I want you to remember is with this pattern, we are talking about two different pieces of software. We're talking about, you know what? This thing here that I am calling a client is a hardware device. That box there, or the oval or whatever picture you use, is representing a physical device. And inside of that device, we have some kind of software running. And that software could be, in the simple scenario, that software could be only one class. This one class with a main method here. That class alone, one object, is running in this computer or in that phone or in that device, whatever that is. And here, in the other, this one that we call the server, is just another computer. more powerful than the former one. Another hardware. And inside of this hardware is running another program that could be another class, also with a main method. This is the first time that we're talking about a pattern. And that pattern considers two programs, two main methods. We need one main for the client or the software running in what we call the client, and another main for the software that is running in what we call the server. Two different classes, two different pieces of software. Now, these arrows here and these arrows here do not represent anything related with UML. It's not association, composition, nothing. It's just connection between one computer and the other computer with something else. Hardware that represent, in this case, the internet. Or if you want a local area network or whatever, physical connection between two hardwares, two computers, a computer and a phone, whatever. Two hardware devices connected with something that is able to provide infrastructure for those two to communicate. My phone, the internet, and my computer. One laptop, another laptop, and a local area network. The diagram of the architecture is all about hardware, physical connections, not about software. Question for you guys. If this software is running in this computer and this software is running in this computer, and somehow we are going to make this software be like Canvas and this software will be like the browser in your computer. So these two are going to be communicating, sharing information, whatever. In a class diagram, there is a connection between these two classes. In the architectural diagram, there are connections. I am showing you that. But when we move to the class diagram, one class, another class, one program, another program. Do we connect the classes? And it's a question in your exam, yes or no? And hopefully, okay, thank you. Hopefully you agree with the no in the chat. Hopefully those two no's represent the agreement of everyone. Guys, a pretty common error when we are talking about client and server, very common error for the students to create a class diagram and somehow connect these two classes. Never do that. The classes are not connected. They are two different pieces of software. And the connection that you put between the classes is calling a method or creating a variable. And that cannot happen if you do not have the source code locally. So never do this. Exactly. They do not communicate directly. I fully agree with that. So
just to clarify something. So you say that line should represent calling a method. So would you use that in the case of like a API, like where you're calling a non-local method?
Let me show you that. Yeah. Think about this. If you have a client and a server, and I am going to do this thing. Think about you have in your computer, your laptop. You are going to run a program. That program, the easy one, is going to have at least one class. So you're going to have one class A running in your computer. You have that in your environment. And in my computer, I am going to do another program. And my program is going to have another class. I can use the same name. I am going to use different names used to identify them, but for sure you have a main, and well, I am going to have a main. That is what we have. Now, the question, and I am going to move forward from that question, is, well, what happens if we want to connect our programs? What happens if, for instance, you are doing in your computer something like Canvas, something like a program that is able to create quizzes? And what happens if I, in my computer, want to access what you are doing and maybe take a quiz? One quiz that you created, I want to have access and I want to be able to answer and send my answers to you because you are the ones that are going to be able to grade it. Something that happened with Canva, right? So we have this idea of two different pieces of software. One that is going to create the quizzes in your computer, another in my computer that want to access that information. Immediately, you are going to think like a client-server application. We have a server like Canvas or like your application, and the one that want to use the information is the client. It's a client-server application, no doubt about it. What we do to connect them? Well, in order to connect them, we're going to use a library. Yes, as you mentioned, I am sure that should be a library in Java that we can use to communicate a program from one computer with a program in another computer. For sure, there is a library.
What did you just?
The library, in fact, in particular in Java, that library is a package java.net. And let me be clear. You and I, the people developing this software and the people developing this software, we both need to use that library in order to create the client or the server. We need that library. Why? Because that library have two particular classes that we can use for network communication. That library, one of the classes inside of this library is a class socket. It's a class, and it's inside of the library. Another class inside of the library is a class server socket. It's another class, and it's in the library. Yeah, socket. If I have the library here, I have those two classes. You have those in your developer environment. And if I have the same package in my developer environment, I am going to have also the class socket. And I am going to have also the class server socket. You know what? I want to create a server. I want to create this program that is able to receive communication from other programs in a different computer. What you can do is, as you described, a connection between your class and the class server socket. And you know what are you going to do? You're going to be calling methods in that class. That is what you're going to do. You're going to connect your class with a library. The library have a class. That class have methods. And those methods there, somehow, those methods are able to send information to another computer using an IP address. Or those methods are able to receive information from another computer using an IP address. How that happens is something that is inside of those methods. Instructions inside of those methods. The only thing that you are doing in your class A or in your system is to use those methods, and therefore you have a connection between your class, your software, and that class in that library. That connection, association, or maybe you create this server socket as a global variable, and therefore it's going to be aggregation composition. I do not know, but it's going to be used this connection. And similar The people that is doing this other program, probably this one is going to be used the client. And for these people, the client, I am going to be using socket. We both have the library. We both are connecting our software, A and B, with something in a library. But there is no connection in terms of the class diagram between this software and this software, because think about it. They are two programs. Each program has its own class diagram. This is the blueprint for Canvas, and the other, this one, is maybe the blueprint for the browser that you are using to access Canvas. Two different pieces of software, two different blueprints, one blueprint for each. The connection between them is not calling a method, is not creating a variable, because they do not exist in the same computer. The connection, this sending data across the internet, is not something that you represent with UML. Yeah, it's something that is going to happen between the server socket and the socket. The reason because these classes exist is because they have methods to do that, sending and receiving data through the network. But that connection, you do not represent that in a UML diagram. That is represented in the architecture. Clear? And hopefully, yes. Because remember, in the class diagram, the only thing that you can represent every single time that you put a line, that line is representing inheritance. You cannot do inheritance if you do not have both classes in the same computer. Global variable, you cannot have a global variable from another class if that other class is not in your computer. Calling a method, you cannot call a method from a class that is not in your computer. So there is no connection between sockets, or there is no connection between A and B, not in the class diagram. However, they probably, because of the socket, they are sharing information in a network connection physically. In the architecture, that is happening. In the class diagram, one class diagram here, another class diagram here, two different pieces of software. Good? So let me show you the source code. I just mentioned the class diagram source code, and this is something that you can find in the tutorial. Again, something that I am asking you to do is to review sockets and server socket in Java, because we're going to do a program with this. The goal, the next assignment, is to put together these patterns, client server, Blackboard, and model view controller. So I am asking you to review the source code, and if you need, please review multi-threading, Runnable, thread, and also network communication with Java, socket and server socket. I am just showing you the beginning, the example. This is the source code, the simple one for a server. And you can notice the server can be used one class. You need this package, the package that is going to help you to use the internet in a program. The class server is going to have at least one method, the main. And the only thing that you need to do network communication is an object from this class. What is the parameter here? Any idea? What is that number? 6666. Yes, the port. Hopefully you're familiar with this. You reviewed this in a different class, but every single application running in your computer that is able to receive or to create a connection with another computer need a port. The ports have a number, and well, Usually, any port bigger than 1024 is a free port that you can use. The others, the numbers that are lower than this, usually have some kind of standard reason and they are in use for the system. So good recommendation for your software, whatever you do, if you're going to use a port, try to use numbers that are bigger than that. So this is a safe play. It's a big number. In that port, my server is going to be listening connections. That is the method for the server socket to wait, literally to wait. If I am a server socket, I am going to be there running. You can imagine an infinite loop. And the only thing is I am waiting to receive a connection. I am waiting for a browser or for an application to connect with me. After the connection happens, you can move down, moving down, establish the connection. The connection can be binary or string. In this example, use a string. And I am sure that you're going to find all of this familiar because basically this is exactly the same thing or similar to what you do when you read or write data in a file in your disk. Making a connection with another computer is almost the same that making a connection to get information from a file in your own computer. It's a stream of data. Obviously, the difference is you need sockets. This is the server. You can copy paste the code and have this running. This is the client. One class, one main. And you can notice here the same port, but the object is use a socket, not a server socket. The server socket is the one waiting for the connection. The socket is the one that is going to ask to connect. If you notice, the only connection, the link between these two programs is this number. This guy is waiting for a connection in that port. This guy is asking for a connection in the same port. That is the number that is going to connect the two programs. And as you can notice, this is similar to working with files. The other, the server, is going to read or write. The client is going to do the opposite, reading or writing. Obviously, exceptions can happen, just like with the files. Review this, review this. Be sure that you can create this connection. Now, something that you could be wondering, well, but you mentioned that is one file and another file, one program, another program in two different computers. Can I run this one and this one in the same computer? And the answer is, yeah, you can do that. There are two programs. Yeah. Good news, your computer can run more than one program at the same time. So you can run these two, the client and the server. Both are going to be communicating, not because they are in the same computer, but one is going to be writing in the port and the other is going to be reading from that port. So you can run both in the same computer. It's going to work. You can run one in one computer, one in a different one. You can play with a friend. Just be sure that the network in which you are working do not have any issue with security, firewalls, things like that. But you should be able to run in different computers, one and the other, the client and the server. So that's it. Client server, the source code, Blackboard, the source code, and model view controller, the source code. Your homework. Review that because next lecture, I want to talk about your next assignment. Any question? Good. So remember, no lecture on Monday. So see you in 1 week to talk about a new assignment. See you next week. Thank you.